Hello everyone, this is part second of the first video, that is the important numerical problems based on the electricity chapter. So let us all start with question number 8 now. So what does question number 8 says? That a potential difference of 4 volt is applied to two resistors 6 and 2 ohm connected in series. Okay, so V is equal to 4 ohm and R1 is equal to 6 ohm, R2 is equal to 2 ohm. Calculate the combined resistance since they both are in series. So 6 plus 2, that is R1 plus R2, that will be 6 plus 2, it will be 8 ohm. Okay, then the current flowing in it, that is V is equal to IR, then I is equal to V upon R. It will be 4 by 8, that is 1 by 2, it is 1 by 2, right, and that will be 0.5 ampere. So we have found this also, and then we have to find out that what is the potential difference across the 6 ohm resistor. So now let us all try to understand that if this is resistor 1 of 6 ohm, this is 2 ohm, right, and this is a potential difference of 4 ohm that is applied. Now in a series combination, the potential difference is different across each resistor. So now if this is R1, okay, current will be the same that we have found. It will be 0.5 ampere everywhere. So we will apply the formula V1 because we have to find out the potential difference across R1, okay, 6 ohm. So that will be V1 is equal to IR1. Now I is same, so we keep it as I. So V is equal to 0.5 into 6, V1 is equal to 3 volt. So this voltmeter will show us the reading of 3 volt over here. So this is how we solve question number 8. Okay, now question number 9, that a potential difference of 6 volt is applied to two resistor 3 ohm and 6 ohm in parallel to each other. Okay, so if this is how we can imagine the situation to be, they both are parallel to each other, and this is a battery or a cell that is connected 6 volt, 3 ohm and 6 ohm. Calculate the combined resistance. So that will be 1 upon Rp is equal to 1 upon 3 plus 1 upon 6. It will be 6, 2 plus 1 is equal to 1 upon Rp. 3 by 6, it will be 1 by 2, and Rp is equal to 2 ohm. Okay, so we are getting the answer as 2 ohm. A part is done. The current flowing, now V is equal to IR, I is equal to V upon R. So this is the total current, so V should be total and R should be total. Total potential is 6, total current is 2, so the total, sorry, resistance is 2, current comes out to be 3 ampere. So this is the answer to the second one. We have to find out the total current, so potential and resistance should also be total. Now the current flowing through 3 ohm, now 3 ohm, now we have to see that this is a parallel combination, and in a parallel combination the potential will be same, that is it will be 6 volt across 3 ohm, it will be 6 volt across 6 ohm, but current will be different. Okay, so how are we going to find out the current across 3 ohm? So we will apply the formula V is equal to I1, and if 3 ohm was R1 and 6 ohm was R2, so we will be writing R1. Right, now why V remains V? Because it is parallel and potential will be the same. So I1 will be equal to V upon R1, and it will be 6 by 3, and the value of current through R1 comes out to be 2 ampere. Okay, so most important thing over here is that we know that in a parallel combination potential remains same everywhere, and in a series combination it is the current that remains same everywhere. Okay, now question number 10, that in a circuit the voltmeter reads 10 volt. Okay, there is a voltmeter, right, it reads 10 volt. What is the combined resistance? So we all can see that the two resistances are in series, so it will be 2 plus 3, that is 5 ohm. Answer to A part. Then what current flows through this? So current, they are asking, the total potential is 10 volt, So V is equal to IR, I is equal to V upon R. V is 10 volt given in the question. R total we have just found out 5, and it will be 2 ampere. The total, the current that will flow through it. The potential difference across 2 ohm resistor. Now again, it is a series combination. Potential will be different across each one of them. So now if 2 ohm is R1, it is R2. So it will be V1 is equal to IR1. Why I? I is same everywhere. It is a series combination. So V1 is equal to 2 into 2. V1 is equal to 4 volt. That is across this. The reading of the voltmeter will come out to be 4 volt. Okay. Now the last one, the potential difference across 3 volt. Now 3 volt is R2. So it will be V2 is equal to IR2. Now why IR2? Because current is same. So 2 into R2 is 3. So the value of potential difference across the second resistor will be 6 volt. And how do we get to know that our answer is correct? See, 4 and 6, that is 10 volt, and the total potential applied was also 10 volt. So this is how we solve question number 10. Now moving on to question number 11, it's also easy. That in the circuit given below, what is the combined resistance? Now we see the circuit, we get to know if this is R1 and R2, both are parallel to each other, because over here the charge gets two paths to flow, first and second. Okay, so 1 upon Rp is equal to 1 by 3 plus 1 by 6. It is 6. 2 plus 1 is equal to 1 upon Rp. It is 3 by 6, that is 1 by 2 is equal to 1 by Rp. We find the value of Rp, so that comes out to be 2 ohm. Part A done. Moving to part B. What is the potential difference across the combined resistance? Now the total resistance, that is we have to find out the uh, potential difference across the combined resistance. Combined, so now we will apply the formula, that is V is equal to IR and V is equal to, now I value is given to us 6. We have to find out the combined. Combined means it is the total resistance. Okay, so total current is 6, we all can see, and the total resistance value we have just found 2, so it is 12 volt. So we have found out the total value of the potential difference. Okay, combined resistance means the total potential. Now what potential difference across 3 ohm? Now since it is a parallel combination, so the potential remains same everywhere, so it will be 12 volt across 3 as well as across 6 also. Now what is the current in the 3 ohm resistor? Now since it is parallel, current will be different. Now we are thinking that 3 ohm is R1, so it will be V is equal to I1 R1. V is equal to V upon R1 will be giving us the value of I1. So V is equal to 12 and R1 is equal to 3. And what is the answer? Across 3 ohm, right, across 3 ohm, and the value comes out to be 4 ampere for the I1. Okay, moving on to the 6 ohm resistor. So that is R2, so that will be V is equal to I2 R2. I2 is equal to V upon R2, that is 12 by 6, and the answer comes out to be 2 ampere. And if we do the addition of 2 ampere and 4 ampere, that comes out to be 6 ampere, which was the total current. So this is how this question is also done. Right, now moving on to the next one, that is the 12th question, that is a current of 4 ampere. So this is I 4 ampere flows through a 12 volt car headlight, that is V, for 10 minutes, that is T. How much energy transfer occurred during this time, that is E, they are asking us. So now out of all the formulae for E, we have one formula, that is VIT. But remember that whenever we find out the energy transfer, time should be in R, and 10 minute is equal to 1 by 6 R. We divide it by 60 and we get 1 by 6 R. Now it is easy. V is 12, okay, I is 4, and T is 1 by 6. Okay, we can convert it into like this also, 1 by 6. So this will be 2 and 3, and this will be 4. Okay, so it will be 4, or maybe we can change this into one more. It will be V into I is power watt hour. Okay, so we are finding this answer in watt hour right now. There is another way of doing it, that we find the energy in joules. That is also absolutely correct. And if we want to find the energy in joules, we will not change it into minute, but we will change it into second. So in that case it will be 600 second. So we can apply the other energy formula for it. Formula not like the unit for energy, VIT. So it will be 12 into 4 into 600, and it will be 28800 joule. Okay, so this is the energy transferred. Now moving to question number 13, that is a bulb rated 200 volt and 100 watt. What is its resistance? Okay, so this is the potential, this is the power, resistance they are asking us. 5 such bulbs, so there are 5 bulbs, they burn for 4 hours. What is the electrical energy consumed E? Calculate the cost if the rate is 4.60 rupees per unit. So it is also very easy. We all know that there is one formula, P is equal to V square upon R. Rearrange it, we get V square upon P. Okay, V square upon P. So it will be 200 into 200 upon 100. We divide it, and the resistance comes out to be 400 ohm. So we have found the first part of the question from the formula P is equal to V square upon R. Now moving to the second part of the question. Now they are asking, we have to find out the energy consumed, and since the cost also we have to find out, energy consumed should be in kilowatt hour. Okay, so now let us all find out that what is the total cost. So we all know that P is equal to E upon T, and energy we have to find out, it will be P into T. Power is given to us as 100, so we'll put 100. Time is given to us 4 hour, so this is 4. It comes out to be 400 watt hour. But remember, energy consumed should be in kilowatt hour, so we will divide it by 1000 and we get 0.4 kilowatt hour, right? But it is for one bulb, right? Total how many bulbs are given? 5. So we have to multiply it by 5, and we get the answer as 2 kilowatt hour. Okay, 0.4 into 5 is 2 kilowatt per hour. So that is the energy consumed by 5 bulbs. Remember, we have to multiply that by 5. Now the cost of 1 unit is called 1 kilowatt hour, is 4.6. So here we have 2 units. एक यूनिट का कॉस्ट 4.60 है, तो 2 यूनिट का कितना होगा? वी विल मल्टीप्लाई 2 विद 4.60. It will be 9.2 rupees. So this is the answer to the question, 9.2 rupees. So here I end the second part of the video. 14th, 15th and 16th question will be discussed in the third part of the video. Thank you.